We'll get started in about 30 seconds. All right, well, thank you for joining us today for our webinar. I am Kelly Hill, Executive Editor of RCR Wireless News, and you can find us at rcrwireless.com for all of your telecom news. Your panelists for today, I will be your moderator. We're joined by Ian Gillett, who is President and Founder of IGR, Alex Resnick, who serves as Chair of the ETSI Multi-Access Edge Computing Industry Standards Group, Max Cohen, who is in Business Development for North America in the telco service provider segment for NVIDIA. And then we also have Jeff Sharp, who's Director of Product Strategy at AD-Link Technology. All right, so just pulling a few things out of the news, and this is all very, very recent. And this was from today in terms of edge computing company Vapor.io saying that it's going to be using its Series C funding to stand up 100 micro data centers in the 2020 timeframe. Vizona Networks just announced earlier this week that it has a national deployment with a top MNO in the Americas. They have an edge solution that works with traffic steering for optimization. And it says that its solutions are now deployed on 150,000 sites. That's in 3G and LTE. NTT Docomo announced that it was going to start a proof of concept for video IoT that leverages MEC, and it also announced that it was making an investment in Cloudian for AI data processing at the edge. Meanwhile, just today we also had a London-based startup called Ori opening up what it's calling its DNA mobile edge computing platform for pilot projects. In other words, there's a lot of things going on right now in this space. So we do have a special report, a special editorial report on this available as a free download. That should be up later today on the RCR Wireless News site under the tab Reports. Just a few key takeaways. Multi-access edge computing is the concept of bringing compute, storage, and analytics capabilities closer to the end user and create a service-oriented environment at the network edge that can be monetized. This is being explored in 4G already, but it's a foundational technology for 5G. Most of the folks that I talked to thought that we'd see this being pushed in phases, from a middle-heavy architecture at first, eventually all the way to the cell tower. We have a lot of work in terms of trials and testing going on, and sort of what's happening in conjunction with this as well is network transformation, everything from virtualization and cloud native re-architecting of applications that will really be key to deploying multi-access edge computing. Some of the challenges: physical aspects, citing power cooling as you're putting all of these compute resources in non-data center environments, security. But one of the things that quite a few folks mentioned is this idea of really establishing good relationships with application developers and actually instituting a seamless application deployment process that doesn't take months and months to get these things into the network. So from there, we will move into Ian Gillett's presentation. I do want to encourage all of you to use the user interface, submit your questions as folks are giving their presentations, and we will have quite a bit of discussion time once we get through all of these. So with that, Ian, take it away.
Great, thank you, Kelly, and good morning, good afternoon, everybody. So what I'm going to do, I've literally got 3 or 4 slides here, and I thought I'd start with actually defining 5G and where Edge fits in within this. As we get into certainly to Alex's presentation, he's going to drill down a little bit more in terms of the standards and how MEC fits in and things like this. But I thought I'd start with this. This is, of course, the 5G. Some people call it the Trinity Triangle or the 5G Trinity. But basically, the 3 things that 5G is going to deliver for us. We start at the bottom left there, of course. The big thing is enhanced mobile broadband, or including fixed wireless as well. That's what we'll see first. That's really part of phase 1 with release 15. The massive IoT machine-type communications, things like some of the smart city stuff, asset tracking, some of the big sensor networks, things like this. That really comes in part in phase 2, which is release 16 and 17 of the standards. And the reason that comes in a little later is we do need a enhanced packet core for that. So there's some work to be done. So the first phase, phase one, is really enhance the air interface and get the bandwidth up. The second part is work on the, let's call it quote unquote, the management of the network, but enhancing that EPC. Now, the third part of it is this low latency and ultra reliable communications. And so things like augmented reality, virtual reality, my personal favorite, remote surgery, but a lot of the industrial automation applications, transportation applications, where you really need lower latency down in the sub 10 millisecond range. I call that, that's the along the way. You don't actually need 5G standards to do that. You can do it with LTE today, and we'll talk about that in a few seconds. But those are the three things that 5G is going to provide us, just as a very quick summary. So Callie, if you go to the next slide. So one of the big things, of course, is the enterprise edge opportunities. We do see a lot of activities. Kelly said there's been a lot of activity in general in edge compute and MEC recently. What we're seeing is a lot more activity on the enterprise side. Frankly, the carriers have very big networks, and it does take time to get things, new solutions into their networks. And of course, MEC is no different there. But on the enterprise side, of course, you could have a nice manufacturing plant or a transportation hub, a warehouse that's relatively self-contained. And so you can put in some enterprise edge solutions there relatively easily. And that's what we see today. So we see quite a lot of activity on the private network side, certainly with industrial IoT in terms of aggregating sensors and inputs from different disparate systems. Certainly network slicing will come into this, where certain parts of the spectrum of the network will be dedicated to specific applications. And the thing I like, the last one, is things we haven't thought of yet. I think that edge compute has this great potential to have put some, a bunch of smart guys in a garage with some startup seed money, and let's see what they can do with a developer kit, et cetera, et cetera. They don't have to build the hardware. They don't have to build the networks. That's all there. What they have to do is develop the applications. So if you just click one more time, so I look at MEC as it's a re-architecting of the mobile network. We're moving stuff from the core out to the edge and putting more capabilities at the edge. It's also and this is a word I created, ITization of the mobile network. MEC is really, and edge compute is really where the IT world really meets the mobile world. And they don't speak the same languages necessarily. There's a lot of work to do there, and certainly Alex will be able to talk about all the work he's done through ETSI with other standards bodies looking at different parts of the industry. But this is where, the IT guy in a manufacturing plant meets the mobile operator network engineer, and they've got to work out how to connect their two networks, environments, applications, etc. So it's kind of cool. It's kind of neat. So next slide. So I talked about the latency, and I said that we could do this today. We could get lower latency with 4G. We can get much lower latency with 5G as well, but this is pretty much today how the latency adds up within a 4G LTE network. And if we start from the left-hand side with the device, you go up to the radio, of course, on the tower. You go down the tower into the cell processing or the baseband. Then you go through the backhaul into the packet core, out to the internet, and then you've got your application sitting in this data center out there on the edge. Round trip on that is around 70 milliseconds. I think the average is actually about 78 milliseconds. Let's call it 70 milliseconds. So one way is about 35 milliseconds. And you can see where this breaks out. The backhaul is about 10 milliseconds, the packet core about 4, et cetera, as we go along. Now, if we go to the next slide, all I'm doing here is moving the application or content server. I've moved it from the data center in the core there in the internet. I've moved it so it sits next to my baseband processing somewhere at the bottom of the tower in a local data center or something like this, but certainly on the left-hand side of the packet core. Now I'm looking at latency around 15 milliseconds one way, 30 milliseconds round trip, if not faster. If you actually add up my numbers there, it actually comes out to about 10 milliseconds one way plus some processing on the server. So you get a high performance server in there and you can get some much lower latency. So already our latency's gone from 70 milliseconds or so down to 20 to 30 milliseconds. And all we've done is move the stuff, the application, the content, moved it into an edge data center, some processing. So if we go to the next slide, the final step of this, and this is how you get down to, oops, oh, I didn't have that, okay, thank you. This is how you get down under 10 milliseconds here, is you start putting in some high performance radio and high performance baseband. So start doing some traffic steering and prioritization on the radio. It actually recognizes the traffic and steers it accordingly. And we can now get down to a less than 10 millisecond round trip. Again, my numbers don't quite add up here, and that's intentional because it does depend on that server. It's no good having a fast radio and a fast cell processing if you've got a really slow server that's all backed up and can't handle the load. And certainly Jeff is going to get into that in a few seconds. So that was my quick introduction. That's kind of setting the stage here for everybody else, and I'll hand back to you, Kelly.
Go ahead and we'll move on to Alex's presentation. Alex is the chair of the ETSI, ISG. So Alex, let's go ahead and have you go.
Yep. Thank you, Kelly, and thank you, Ian, and welcome everyone. Well, this slide, as you can see, is what happens when you try and squeeze about 30 minutes worth of presentation into 5. But the idea of this slide is just to start out by giving people an idea of where ETSI MEC fits into the whole MEC ecosystem and the kinds of things that we're doing and trying to accomplish. First and foremost, of course, we are a standardization group, and what we do at the highest level is we define the APIs that network operators would need to have in order to manage the whole scope of these distributed edge clouds around their network. So this is a high-scale, highly distributed network of small clouds, but it has to be managed in a way that's kind of similar to the way that ETSI NFV is managed, right? The other aspect is offering of services to the applications that run in these clouds. Making sure that these applications can run effectively, efficiently, but also exposing the kinds of things that they're going to need, from radio network information to highly contextualized location information, and exposing it in a way that makes sense for application developers, right? For consumers of these APIs, right? So in that, the role that we fill is highly complementary to what other organizations are doing. We've highlighted 3GPP here, right? 3GPP defines how that 5G mobile network is going to work. They're also, through things like NEF, are exposing are saying, hey, there's certain information that we are going to make available to external entities like application providers, but they're not going into the details of how that information, what is the right way to present and create a service out of that information that makes sense for application developers, right? And that's one of the areas where ETSI MEC steps in. Building on that, a couple of other key things that ETSI MEC is doing. We're taking our APIs and they're all published as source code, essentially serialized YAML and JSON. It's available on the site that you see there in the lower left corner called Etsy Forge, forge.etsy.org. And you can just go in and grab it. It is an open API / Swagger hub, so all the things that you're used to with an open API side, it fits in there. Then we've been running, like Etsy MEC, a series of proof of concepts. Let's just go back to the previous slide quickly, Kelly. But that's been expanding now into MEC hackathons. We are going to run a first hackathon in 2 weeks at the Edge Compute Congress that's going on. And there's a number of white papers that we've published, kind of trying to help the community and understand how to build systems, right? Any particular standard doesn't necessarily explain to you how to build a system, and you have to put that together from bits and pieces. Well, we're putting out these white papers to kind of help the community figure that out. You can see the membership list. I'm gonna not go into that in the interest of time. Let's just go into the next slide. Talk a little bit what we've done. From a standardization point of view, we really see ourselves as the foundation for computing at the edge. So from an application enablement, right, an API framework, a set of key services that have to be there, such as service registry, traffic redirection, etc. Right, a set of principles for how you write APIs, because there's going to be a set of services that that people are going to be defining, which are going to go well beyond what we define in Etsy MEC. A set of service-specific KPIs. So there were a couple of services which we've identified as a community and said these are key services that will be broadly used. For example, radio network information, location services. So those APIs are defined, and then management and orchestration are related APIs, right? Let's go back to, or let's go to the next slide. Gone too far. There we go. So that's kind of how we see ourselves, and you can see those kinds of the service APIs, the standards documents. Everything sort of below MEC 20 or so has been published. It is a published official Etsy standard or an Etsy report, depending on what it is, and you can go and look at it, and that sort of comprises our release 1, a set of basic standards. We're now working on release 2 that updates those, and also we're working on a new set of standards that complements those, and I'll get into those into some details on the next slide. So let's go to that next slide. Okay, that's the scope of MEC Phase 2. You can see there's 2 documents that are indicated as ready. MEC 22 is a report on support for essentially vehicular automation that's published. The lawful intercept is indicated as ready. We're gonna, for logistical reasons, we have to delay the publication for a couple of months, but you can sort of see from a standards investigation effort where the focus of Phase 2 is. It's things like application mobility network slicing, and then exposing additional information services for wireless LAN, for fixed access, and support of specific use cases where we started with the vehicular, but we do plan to expand that to others, right? You can see the name change for those of you who have been monitoring this group. We started out as a mobile edge computing group because the idea was, well, we'll standardize the service APIs for 3GPP, but in fact, we realized what we're doing, with some very few exceptions, it applies equally to all types of access networks. So therefore, the name change to multi-access edge computing. Let's go to the next slide. So this is going to be my last slide. I'm going to let others sort of dive into a lot of the details, but this is a MEC and 5G webinar, and I was asked to present what Etsy MEC is. Let's talk about a little bit, not just how Etsy MEC, but how MEC fits into the 5G roadmap. And Ian hinted at this already a bit, but I really like to go a little bit deeper into this. Think of 5G as the 5G applications that are going to be delivered over these networks. Okay, they're not because that's the ultimate goal. It's not deploying the radio access network of 5G. It's not deploying the core network. It's enabling these applications. It's monetizing these applications, right? As I talk to operators, and I have as my primary responsibility a very operator-facing kind of a position, one of the concerns that they have is, hey, we have this deja vu feeling. We've been here in 4G. We're being asked to make a huge investment on the speculation that the money is going to come. And then what happened with 4G is the money actually did come, but a huge chunk of it, if not the majority of it, went to somebody else. So there is a real concern with 5G. If we're going to make this huge investment across the board, how do we monetize it? How do we make sure that we're making an investment against some reality in terms of making a return on it? Well, MEC gives you a way to approach it in a, let's say, more business-friendly and steady fashion. If you look at these applications and you think about 4G LTE network, with very few exceptions, you can deploy them on a 4G LTE network as a pilot, right? The only thing you really need is you need an application landing zone close to your radio access network, which means that you need MEC. Which means that MEC now gives you a way to introduce your 5G, your real 5G money-making applications into your network, pilot them out to your customers, start getting an understanding of how they're used, experiment with business cases. As these things pick up, as you start seeing the revenue coming in as an operator, you will need to scale it, and then at that point you will almost certainly need a 5G RAN, a 5G core network, but you're investing in those because you have a revenue source that is pushing against the capabilities of your existing network, right? So you're not making a speculative investment. And that's sort of the key role of 5G. All right?
Great.
And I'm done.
Wonderful. Thank you so much, Alex. Really appreciate it. And now we're going to move on to, and just so you guys know, Alex's contact information is there. Max Cohen from NVIDIA.
Good afternoon, everyone.
Max. There we go.
Yep. Hey, everyone. Good afternoon. Yeah. So, from NVIDIA's perspective, I'll keep this a little bit less sort of, let's just sort of say slide-centric, but just kind of talk as an overview of where we see really the technology evolving, and to kind of dovetail off of some of Alex's slides. I think the biggest thing that we're acknowledging in this space of 5G is really going to be the amount of compute that's going to be necessary to handle really just the way the things like massive MIMO, the RAN, and really just handling the amount of traffic that's going to be needed. And so we're looking at this from a couple different angles. One particular angle is looking at AI to help manage that process and do a better job at really kind of predicting and optimizing the network. And then really from a computing standpoint, really being able to look at some of the network functions and where the GPU may be able to offer some acceleration compared to some of the traditional compute type of chips. And being able to kind of marry the two around AI and accelerated computing, the virtualized sense, is really where we've kind of got a laser focus on right now. So we're working very closely with operators and network providers to really work on a next generation architecture for that. And in terms of edge computing, we really see, from a general sense, we talked about use cases, really having the ability to look at some of these next generation immersive type use cases around VR and AR, or video streaming, or edge analytics, the video analytics, where the GPU can really help power some of those particular types of use cases from a computing standpoint, and more importantly, start to continue to drive AI at the edge when more and more enterprise organizations look to bring AI into their business. They're going to be relying on the operators and the network to be operating at real-time inferencing, real-time AI. So those are kind of really the high-level areas where NVIDIA is really kind of focused on, and we really believe that these partnerships across the board are really going to help continue to enable and drive some of these use cases within the operator space.
Okay. Any other thoughts, Max? Because if not, we'll go ahead and. Okay.
Oh, sorry.
Great. Well, then we'll go ahead and we'll go on. We'll go on to Jeff's presentation, and Jeff Sharp of AD-Link.
Thanks, Kelly. And man, this is great being the last guy, because man, everyone else has built that foundation and put the framing up for the walls, and all I got to do is finish up. This is awesome. From an AD-Link perspective, just as Alex and Ian and Max has talked about, with MEC, we actually define MEC in multiple categories. Of course, you have the ETSI version of MEC, but we also see the edge as edge at the various cloud environments that are being instituted, and not just the mobile network, but the landline business, the internet provider, and the cable businesses. All these networks are becoming to merge together. So if you think of networks moving into a virtualized cloud environment, along with a service-defined network environment, you're seeing access clouds, forwarding clouds, which are the access into other carriers and the internet itself. And then you have the control plane cloud. And all of these are your traditional network functions that are part of the networks that are becoming more and more virtualized in nature. And where we see the actual edge is really the edges of these individual clouds. If you could just do a click, and it'll kind of come up with a, there we go. So where we see some of the edges are of not just the edge to the consumer, to the enterprise businesses, but we also see the borders within these individual cloud environments. And each of these environments, as Ian was talking about, and of course Alex, they all have different environmental elements. Some are at the radio tower itself, which sometimes in a picocell environment have to be outside. Some are in small enclosures that the depth is not as deep as a normal rack mount server environment. And then of course the central offices are also environments that you can put equipment, but you have that NEBS level, that carrier grade level of environments. And then you also have the normal data center environments, which sometimes the equipment is much different. And what we've done is we've taken an approach of open architectures in which we look at the hardware that's placed in all of these different areas within the borders, the edge, on using reusable assets that can actually fit in each of these different environments. Next slide, and I'll go into a little bit more detail with that. At a very high level, these are some of the edge applications. Go back. These are some of the edge applications that we're seeing in proof of concepts and are deploying today. And I'm not going to go through every one of the bullet points, but the key aspect of this is really around the scaling applications, things like resolution, media transformation, things that require lots of bandwidth with low latency applications, video to text, speech to text, translations, video communications, both from a media and also live communications. You have local connectivity, which is really that enterprise portion that Ian did a great job on talking about. That virtual CPE, customer premise equipment, dedicated routing for specific customers, enterprise networking, edge broadcasting. Then you also see more and more edge compute for offloading capabilities. These are areas that may require more and more edge compute power, both from an NVIDIA GPU perspective or an Intel high-end Xeon perspective, that can do it right there at the tower or at the central office. These can include both computing and transcoding applications. Also, the other key thing is augmentation. These are areas or applications that go around augmented reality, virtual reality, geolocation. We have caching services, edge content delivery, CDN content. And we're seeing more and more applications around CDN content, primarily around the cable companies, putting more and more Netflix-type services closer to the subscribers. And then we also see the aggregation of networks as well with big data and sensor data especially with 5G becoming more and more broader in terms of the amount of devices that are going to be shipped out, and also the amount of bandwidth that's going to provide within that big data. So we're seeing this real time. Most of these applications are in proof of concept stage now in multiple areas of the network, and security, routing functions, and traffic management functions play a big role in this. Next slide. So for AD-Link and a lot of our partners, we're really focused on edge assets from the local data center really all the way to the user environment. These are low latency applications that sometimes require less than 20 millisecond round robin transport times. And in most instances, your cloud environment that could be regional or actually in another country in some cases, that latency is going to be really hinder the applications are going to be used. So for us, we look at all these different environments for the 20 milliseconds or less, even 10 milliseconds or less, and where that equipment will be placed. So again, going back into open architectures and reusable assets, we want to have the ability to put this environment both in the central office and to the hardened compact server rooms that could happen at the cell towers, and also outdoor servers that can be placed in small remote sites, including Pico sites. So next slide. And around this open architecture environment, AD-Link is dedicated lots of money, resources, time, and energy on providing guidance, and also becoming innovative collaborators within the CORD, the ONF, the ONAP, and the open compute projects. We're heavily involved in all of these different environments because we truly believe the ecosystem is really required, especially in the operator networks, to be successful. So we've partnered up not just with other hardware companies, but also software companies, providing value-added APIs and structure framework that enables this, this open architected environment. And I have to mention, we have some really great partners, and we have Visona, we have Saguna, Tieto, NVIDIA, Intel. I mean, the list goes on, in which we provide valuable assets to the end user using this open architecture environment. Over 2 months ago, we just joined as an innovative collaborator into CORD, MCORD, and ONF. We were just a contributor. Now we're an innovative contributor. And we're also a platinum member with Open Compute Project and the Telecom Infrastructure Project. And of course, with Etsy and others, we've been members as well. Next slide. And as we're progressing from a silicon perspective, we've got a great partnership with NVIDIA. We see the general purpose and GPU servers being a great asset, and the AI and ML space and the operators. Things like analytics, high performance compute, and GPU virtualization is heavily required, especially at the edge where those low latency applications are going to be implemented. On the next slide, in my final slide, I wanted to mention that at the edge, you know, the things that we have to worry about as a supplier are things like self-healing and resiliency at the edge, making sure that that software and hardware is being managed by itself. It is remote. You don't have a craftsperson there having to manage it, so it has to be self-healing and resilient and being up at 99.999% of the time. Also, it has to meet certain cloud architectures for both NFV and SDN, which is why we're heavily involved with a lot of our partners, from Wind River to Ubuntu to Kubernetes, and the list goes on, to ensure that that cloud-based architecture fits well within our hardware-based architecture. And of course, things like automation, artificial intelligence, machine learning is critical, which is one reason why us and NVIDIA and Intel have such great partnerships. And then, of course, we're very, very focused on open software architectures as well. And that's it. Thank you, Kelly.
AT&T, if I remember correctly, that's AT&T's work with the Linux Foundation in terms of a stack for the edge.
That's correct, yes.
And are you guys involved, and do you guys support that, or are you involved with any of the work over there?
We are. We actually have trials going on. We've also got heavy involvement with some of our integrators as well, especially with Cord and MCord, ONAP itself with AT&T, and of course our Open Compute project. So we can't do it by ourselves. We acknowledge that going in with a proprietary environment is not the right strategy, nor is it the right thing for our end customer, because really the mobile operators, they're smart, they're intelligent, they have money, they're deploying a lot of cool things, but they need help. They need guidance from companies like AD-Link and our suppliers. And one thing I'd like to mention is a lot of the startups that we've partnered with, companies like Kickview and Visona and even Saguna and some others, they are doing things that normally, I'm an old Nortel guy, so things like these big, huge tier 1 companies could literally take a longer amount of time to deploy something, where these startups are becoming more and more agile and deploying new products much more quicker, especially in this open network like Cord and ONF and ONAP.
Okay, so we had another question, and this is a fairly complicated one from our audience. My question on the mobility challenge with MEC has to do with the boundaries of the edge. If a user moves from a region whose cells are anchored to a MEC to a region whose cells are anchored on a different MEC, how will the apps follow? How will that handover experience appear seamless? Are there constraints on the user devices that need to support homing to multiple MEC servers? I know I have a feeling multiple folks on this panel can probably speak to that. Ian, I think maybe, would you like to start?
Yeah, so it's a very big question, and Alex and I had this discussion actually, I think it was last year in Berlin at the Edge Congress. There's a whole panel about this. So there's a couple of things to think about. If you've got let's say you've got a MEC island, right? Let's say it's in a shopping area, and there's applications there supporting the local stores, and retail, and things like this. Then maybe that application doesn't need to move anywhere else, right? It's specifically tied to a location to provide specific value. If the application is really designed for people, let's say in cars, as they drive across the city, well, it shouldn't really be in the MEC in the first place. It should be in the packet core, because people are moving all over the place. They're going to need access to it wherever they are. So not all applications reside in the MEC. Not all applications reside in the packet core or in the internet. Some applications do want to move. So a really good example is, imagine you've got two hospitals and they're in the same group. So in one hospital, you've got a set of applications for the doctors. You want it nice and secure, very private. Those doctors may also have need to go to the other hospital, have patients over there, want to access the same applications and the same content. So that's an example where you would want mobility between the two MEC islands. And then what you do in that situation, and I think Alex can talk to this a little bit, is that you would move the state of the application from one MEC island to another as the user moves. So the information about what you've been using would transverse with you and allow that seamless connectivity, if you like.
Yeah. Ian, I was actually typing up an answer to this when Kelly asked the question, and I do think it's a very good question. It comes up all the time. I do so. I'll start with a bit of shameless promotion for MEC. We are working on specifications to put down tools to actually do this. Okay, and because there are going to be applications that are going to have to move. Said that, I will go even farther than Ian in this answer, right? Let's just think about the applications that are going to be running in the edge. One type is going to be, of course, an operator's own VNF. And that has to move, right? And that has to, it's not that it has to move, it has to support user mobility, but guess what? It's a 3GPP function. 3GPP either has or will define for you how to do that, right? And you have to work within the definitions of 3GPP there. So it's not that it's an issue there, but 3GPP needs to solve that issue for you, because that's what they're there for. The other ones are cloud applications, right? And some of them you don't have to move. But even when you do have to move, in most cases, a well-defined cloud application today is likely to be built using a microservices architecture with interconnected with a bunch of RESTful APIs, which means that the instance of a particular service which you're placing at the edge, right? Because you're not placing the whole application, you're placing an application component. That instance in a properly designed application is going to be stateless, which means that your application mobility problem is actually very simple. You just spin up a new instance at a destination point. It does not need any user context to move. It does not need anything that sounds like a handoff. There was just a question about a handoff. Because there is no user context. It's a stateless service, and because it's been properly designed as a web application and it's using RESTful APIs to communicate. Now, I say that, of course, there are going to be applications which will require stateful presence at the edge. And for those, like I said, it's not a handoff. Handoff is a mobile network operation that is, it has been defined by 3GPP and it will continue to be defined by 3GPP. But along with handoff, you're going to need some mechanism to allow application client context to move from one edge site to another. And MEC is currently defining specifications for how to do that, right? That will sort of piggyback on what's going on in the mobile network. Just a word of warning. Customers of
All
applications.
Right, great.
Yeah, don't do
absolutely.
it unless you have to.
Okay. I wanted to ask you folks what you think are some of the challenges to operator strategy and approach. You know, I heard from quite a few people across the spectrum that, you know, the relationships here and operators' own processes are really kind of one of the big things standing in their way. You know, they've long been, you know, we don't want to be dumb pipes. You know, we want to be actively involved in, you know, in applications and, you know, and this application and cloud ecosystem. You know, but there's long, you know, proof of concept, long processes to get new applications into operator networks. You know, 5G is really supposed to be help them create a more agile service environment. But you know, there's I definitely heard a lot of frustration, or I guess a lot of just recognition that you know, they haven't necessarily opened up their network in the past, and that folks are you know, are concerned about their ability to do it in a way that that is actually really helpful and constructive for developers, as opposed to, you know, here's our network, you know, you do things the way that we want you to, and sort of taking that strategy to it, as opposed to, you know, something that's more friendly. Now, I did hear from several people that what they're seeing in proof of concepts and trials is that operators are becoming more open to this. So I'm wondering, you know, if you folks can speak to that. And Jeff, I think I'd like to start with you on that one. I know you guys have been involved in a lot of proof of concepts, and I wonder what you're seeing in terms of how operators are really sort of wrapping their arms around this.
Yeah, thank you, Kelly. And so, yeah, I am actually pleasantly surprised that we're seeing more and more ramp-ups of CTO type activities or foundry-based activities within the operators that are taking on more risk. They're, you know, they're putting more white box environments into their network. They are experimenting, like I said, with these startup companies that seem to be more agile and more acceptable to making changes on the fly of what the operator's needs are. However, it's a long process. We are dealing with the service provider industry that is normally regulated by the government, whether it's a local, state, or federal government, that they have to keep their network. They still are managing an entire network and don't want to introduce risks. So what we're trying to do is in open architecture environments, also open hardware environments, we want to reduce that risk as much as we can by providing not just our hardware, but also a lot of our ecosystem partners in test labs, in foundry areas, in CTO labs to de-risk that final deployment. Sometimes, it's frustrating where you're working with the product teams within those operators and those service providers. They love your program, they love the products, they love the solutions. They see dollar signs. Hey, a lot. This is revenue generating activities, monetization of their network. But once you hit the procurement guys, it's old telco, right? It's the old telecom environment of roadblocks and slowing things down a bit. So it is what it is. I think us and other suppliers within this realm see more progress and more acceptance of these white box and these new open architectures in their network. It's not going to be an overnight thing. I think we all acknowledge that. I do see that getting better and better.
Hey, Kelly.
Ian, thoughts on that?
Yeah, so I'll agree with everything Jeff said. I think also it is managing risk here for the operators. The operators are quite rightly worried. They've got very big networks and they're required to provide a service that's regulated, et cetera, et cetera, et cetera. Now, if you look at my kids and Jeff's kids aren't that much apart in age. My kids have never grown up knowing 5.9's reliability. They don't make voice phone calls. They FaceTime and they Snapchat and they WhatsApp. And they don't care if it doesn't connect within a few seconds because they've never known that. So I think if you move away from that traditional reliability, the network risk becomes different, right? And that helps the operator. If they can move away from, hey, we have to do it this way because we already always have, then it becomes easier for them. But on the other end of the spectrum, you've got somebody like Facebook who's being hauled in front of Congress because maybe they're a little bit too open. Maybe things happen without their control. And an operator looks at that situation and is terrified, right? So we've got those two extremes as that's what we're trying to balance. And so it is managing the risk. It's making sure it's open and you can get more developers in there and they can do cool stuff, but you still need some controls on them and you need to be a little careful with them, make sure that everything is above board and as it should be. And it's a balance. Simple as that. I think it's going to take some time. I think it is getting better. It will continue to get better, but it's probably more generational than it is, seasonal, let's say.
Okay. Alex, I know that Etsy has has recognized this. You guys have you talked during your presentation about, how you guys have put out these APIs and are trying to recognize, what's useful to developers and trying to engage with operators. Do you have perspective on making this a more mutually beneficial relationship?
Yeah. So I mean, what is going on, I think, is there is I think it's part of the place where it's coming from is the desire of the operators to not go into a strategy that says, hey, we're going to make this massive investment again on the belief that if we build it, people will come. That's one part of it, right? But the other part of it is the variety of applications is so broad that it's not always clear to the operators exactly what they want to build and where they want to build it. I mean, it's nice enough to say that you're going to build an edge an edge cloud, but for any given operator, there's maybe a couple of different options where they can do it, and the right place to do it depends on a couple of factors, including what is it going to be used for. Okay. So there has to be this communication with the application providers, right? The problem is that on the other side, in the application world, there's really a mindset that operators are just pipes, and so there isn't the right mechanisms in place to get into a communication with the communication services providers, right? The good news is I see emerging recognition that this has to happen, right? That you can't, that as the applications begin to move from traditional clouds into an edge cloud, you have to have an understanding of what the edge is, what kind of an edge it is, right? And then taking advantage of the kind of services that operators can provide, whether it's the ability to optimize your video encoder for the and match it to what's going on in the network, to things like understanding what the latency is, so that as you are configuring your game components at the edge, you're probably or your AR application, you're properly configuring them for what the latency that this particular network can offer, right? What kind of context it's located in. So all of those things do have to happen. We just need to figure out ways of getting there. Yep.
Okay. I wanted to get Max in here on a question, and I'm wondering if you can talk a little bit about the challenges of MEC from an NVIDIA point of view. You know, Max, you talked about some of the capabilities in terms of AI and processing power. You know, can you speak to what you see happening in terms of challenges for multi-access edge computing?
Yeah, absolutely. So we see, from our standpoint, we kind of look at edge computing a little bit differently, right? Because we're the processor and we kind of connect the user experience to an extent to the compute power. So we look at it kind of from two angles. One is from an operating standpoint for the operators, and what value does that additional horsepower and compute bring to the operators from an infrastructure standpoint. And then the other part of it is from a user experience or let's say a deliverable service standpoint. Obviously, we have things like VR and AR and other sort of immersive type things like video streaming, where our GPUs and our platform really shine as well. So the conversations and our engagements with the operators kind of span that spectrum of what value can there be brought to the edge in this sort of in the compute realm from an operational efficiency standpoint, and that also includes leveraging things like machine learning and building deep learning based models to help optimize the infrastructure and help optimize the experience. So looking at things like SON or SDN and looking at how deep learning can influence the optimization and then also all the way to the user experience of where those GPUs and where that platform can be leveraged for the immersive experience. And so where the intersection becomes is the sort of economies of scale of having a virtualized infrastructure with orders of magnitude of additional compute available to you, and then really paving the way to what applications can ultimately be run on our platform. And that's really kind of where we're at right now, is helping the operators look at some of the kind of the low-hanging fruit use cases. And again, today they're very focused on the visual immersive use cases, because I think those are the ones that show well to executives and get people excited. But I do believe, and I hate to use the term sort of build it and they will come, but there is an element of that here, because the cloud providers did this, right? They built infrastructure, early on with the understanding that there was a definitive maybe exhaustion with C-level executives of spending a significant amount of money on physical infrastructure. So they kind of foresaw that there was going to be a wave of cloud computing. And I think what the operators have in their favor here is that 5G is going to drive a lot of new use cases. Autonomous driving cars, smart cities, lots of low latency, near real-time type applications. And we are, our bread and butter is smart cities, is real-time AI at the edge. We do this outside of the telco space. So this is kind of where we're starting to see this intersection happen. What other markets, what other verticals can the operators, not to say get into, but can there 5G edge computing environments can leverage. And I think healthcare is a good example of one where we're going to start to see more AI at the edge, and the healthcare vertical is going to really need to tap into that real-time edge computing environment. And manufacturing is another one. So,
okay. You know what? I'm going to follow up on that. We've got about 5 minutes left, and what I'd like each one of you to do is talk a little bit about whether you think edge computing is going to be driven by enterprise or consumer use cases, because I heard a variety of perspectives on that, mostly leaning in one direction. But when it comes to scale, what I sort of heard from folks is that people think they see the enterprise use cases being chased first because of the return on investment, and then perhaps getting into more of the consumer-related applications as 5G scales, and and sort of chicken or egg. Is it going to scale first, or is it going to there has to be some kind of a development, a killer app or something that really drives scaling for both MEC and 5G. So I'm curious as to your perspective. Max, maybe we can just keep with you for a second, and because you mentioned healthcare and you mentioned a couple of other things. So enterprise or consumer?
I don't want to be biased, but I think because obviously Nvidia's roots come from gaming, so there's obviously a huge consumer aspect to what we do. But to be honest with you, and this is sort of the message that I've continued to drive to the operators, is I actually think the enterprise is really the place where they're going to need to focus preliminarily and really looking at the scale associated to it. But what I've seen is this balance between wanting to drive visual use cases, so that goes back to AR and VR and cloud gaming, things that they can showcase, which tend to lead to an extent to the consumer side. But I do think that the enterprise is really the place that they're going to want to focus, because if you think about retail, for example, there are retail companies that have no expertise in AI, but are looking to bring, real-time video security analysis to all their stores. Some retailers have thousands of stores. So to me, that's where that makes the most sense.
Okay. Ian, your thoughts on the use cases that will drive this?
Yeah, I think, enterprise in many cases is low-hanging fruit in some respects. If you've got an existing environment, like I said, in manufacturing or in transportation, you've got sensors you want to aggregate before you put new IoT sensors on top, for example. That's a perfect edge application. Maybe you combine with a Wi-Fi network internally or a private LTE, so you don't have to, get involved with a carrier. It's a private, local application and network. So I think there's a lot of things like that that make a lot of sense and we can do today, and certainly that's what we see. I'd agree as well about the AR, VR. Some of this stuff's really complicated, right? And it looks really good on the sci-fi movies, but putting it in practice is really difficult. And you do find that the enterprise necessarily doesn't know all about 4G or 5G networks and how to deploy AR, VR across a network and latency and things. And likewise, the carriers don't know about the intricacies of manufacturing or transportation applications. So there is a natural fit between the two of them. I think from a consumer perspective, you've got to look at it and say, well, what am I going to do with it? AR, VR is certainly one that would lend itself very well to edge compute. The immediate one that comes to mind there is gaming and entertainment. But beyond that, do I need AR, VR? Do I need to put a headset on to cook my eggs in the morning? Show me how to cook eggs, right? So it's a lot of things like smart home type applications. It looks really good. We need all these sensors and thermostats and alarm systems. But in reality, there's a lot of people got by without it for quite some time. And I think that you've got to be a little careful. You've got to say, what are you going to do with it? Who's going to pay for it? And enterprise is willing to.
Yeah. And I would agree with Ian. I think the operators are going to go after the money. Consumers are, going to be spending money, but with the 5G expenses and capital budgets that the operators are going to have to implement for those bigger speeds and support of more devices, more towers, they're going to go after the smart factories, the enterprise business to recoup some of those costs. And really, I think those are the consumers, the enterprise, the bigger businesses and factories will, rely more and more on these different high-speed pipes that the operators can provide than the consumer will. I think both will come into line in the next, past 2020. But I think the low-hanging fruit, I hate to use that term, will really be focused more on the enterprise environment, especially smart factories, energy, utilities, logistics, using 5G and edge computing as that avenue to deploy those services.
Great. Alex, you talked a little bit about using edge computing as a path to 5G, to see what really deserves those that low latency and the network investment. What do you see as driving? Do you see that primarily coming on the enterprise side? Potentially.
Well, definitely enterprise is a big one. I do see some developments in outside of the enterprise side and sort of the public mobile networks where edge cloud system deployment is being bootstrapped to a deployment of a specific application or a specific need that requires compute at the edge, right? So what I see a lot is, or what I see some of, is operators bootstrapping. I need to deploy this. To deploy this, I'm going to deploy it on compute anyway. So why don't I position this compute as a generic cloud in which my driving need is just the first application. And
okay.
Yep.
Okay. Great. Well, thank you all for participating today. The presentation is being recorded and you will be able to access it afterwards. So thank you so much for joining us for the webinar.